Now we're going to think about how your eye controls the amount of light getting into the eye. You know that the light needs to get into the eye to shine on the rod and cone cells in the retina, so that an impulse is sent to your brain to create an image. Now, if there's not enough light getting in, it won't reach the threshold stimulation. Now, whenever we looked at neurons, we knew there was a certain level of stimulation that was needed in order to fire an action potential. So if it's very low light intensity, there may not be enough light hitting the rod cells or the cone cells, and if there's not enough light, we'll not get any action potential. So on the other hand, if it's a very sunny day, or it's very bright light that someone's looking at, too much light intensity can actually damage those sensitive cells, the rod cells and the cone cells. And so the eye has to monitor the light intensity, and it has to respond to make sure that just the right amount of light enters the eye. And it does that by changing the size of the pupil. So if we look at the diagram here, this is the pupil in the middle. Now it looks black, but we said it's not actually a thing. The pupil is just that gap in the middle. The iris is made up of two types of muscle. So it has circular muscle, which obviously looks like that. And then it also has radial muscle, which I will draw in green, just to make it look different. So radial muscle, well, yeah, it radiates out, or it looks like a radius that you're drawing there. Those two types of muscles work antagonistically. If your sister is antagonizing you and you say, do you want to go to the cinema? I want to go. And she'll go, no. Or do you want to go and get some ice cream? No. She'll always say the opposite. So if some antagonistic pairs of muscles, what's the opposite to a muscle contracting? A muscle relaxing. So these two types of muscle, so we've got the radial that I've drawn in green, and the red ones are circular. When one set of muscles is contracting, the other is relaxing. So let's think about a low light intensity. If there's a low light intensity, the pupil needs to get bigger. We need to have a bigger entrance into the eye so we can get as much light in as possible, because it's in short supply. So to get a bigger pupil, what actually happens is the radial muscles will contract. Okay, so they contract, they become shorter and thicker, and that means the circular muscles relax. So if I take a new page here, okay, so I'm not going to draw all the lines here at the moment, but say we started off with a smallish pupil there in the middle. So if those radial muscles, if they contract, that means they get shorter. So they're shortening. And what's happening now is that therefore these muscles have to relax. What has happened is the pupil has got bigger. We say that it dilates. So when there's dim light, the radial muscles contract, circular muscles relax, and that makes the pupil bigger to allow more light into the eye. So when you've got bright light, and there's a danger that too much light would get in and damage the rod cells and the cone cells, This time it's these muscles here that contract. So it's the circular muscles contract. And the radial muscles then have to do the opposite, which is relax. And as you can see, the pupil has got smaller, and we say that the pupil is constricted. And that means it's got smaller, it's going to let less light in and hopefully protect the eye. Okay, thank you.